I am Mr. Nageshar Tambake, Assistant Professor, Department of Mechanical Engineering, Walchenstop Technology, Solapur. Today we are going to discuss design of spur gear, in which we'll see how to calculate the dynamic load, static load. So this is what the learning outcome of this particular session. At the end of this session, learner will be able to derive the effective load on the gear tooth. So we'll recall in the last session what we have discussed, forces on the gear tooth. So this is what we have seen in the last session. So here the PT is the important force that is acting on the gear tooth, which is responsible for driving this particular gear, and PR is the radial force. Pn is nothing but a normal force. Alpha is nothing but a pressure angle. So these are what the components of the forces which are acting on the gear. Tangential force we are calculating with the help of PT is equal to 2 mt upon d. Mt over here is the torque and d is the piece circle diameter. The radial force that we can calculate with the help of PR is equal to PT tan alpha, and tangential force is obtained from mt is equal to 60 into 10 raised to 6 power divided by 2 pi n. So if we know the speed and power, we can able to calculate the torque. So with the help of torque, we can able to calculate tangential force. The value of tangential component therefore depends upon the rated power and the rated speed. The torque required by the driven machine also varies. Balance is obtained by means of a flywheel. So flywheel, that device is maintaining the balance of the speed. Service factor. So in a gear design, the maximum force due to maximum torque is the important criterion. A service factor accounts for variation of power, torque, speed. Therefore, what is service factor that we'll see now? So CS is nothing but maximum torque upon rated torque. So proportionate to this is what the maximum torque upon the rated torque. Now this is the proportionate PT max upon PT. So maximum tangential force upon the rated tangential force, and rearranging the term that we are getting. So PT max is equal to CS PT. So PT max is nothing but what? The maximum tangential force that is required for the gear to transmit the motion. So service factor for electric motor, if we see, that is CS is equal to starting torque upon the rated torque. So service factor for speed reduction gearboxes, that is shown in the table that we can see. So working characteristics of the driving motor is given in the left hand side. If the speed is uniform, working characteristic, if that is uniform, light shock is there, medium shock is there, that is having different values of the service factor. So for a driven machine, driving and driven machine, if we see, we compare, then we are getting, we will take the different value of CS as recommended in this table. Then service factor, example for driving machines with different working characteristics. So here we can see the characteristics of operation, if that is uniform, light shock, medium shock. So different examples of driving machines are given. Electric motor, uniformly that is rotating, steam turbine uniformly rotating, gas turbine is also rotating uniformly, multi-cylinder internal combustion engine, that is having some light shocks because of variable speed, and the medium shock single cylinder internal combustion engine, that is getting the medium shock. The next examples of driven machine with different working characteristics, if we see, so here also some of the driven machines are given over here. So these are having uniform, medium shock and heavy shock. So these are different examples that we can see over here. So according to uniform, medium shock and heavy shock, the different values of the service factors are recommended, according to which we need to consider for the further calculation. Now dynamic load. So for gear rotating at very low speed, almost at zero velocity, the transmitted load PT can be considered to be actual force present between the two machine teeth. These are the important sentences, that is why that are shown over here, that we need to remember while considering the dynamic load. In most of the cases, the gears are rotate at an appreciable speed and it becomes necessary to consider the dynamic force resulting from the impact between the mating teeth. So dynamic force is induced due to different factors. These are some of the factors: inaccuracies of the tooth profile, errors in tooth spacing, misalignment between the bearings, and elasticity of the parts, and inertia of the rotating discs. So these are what different inaccuracies, or we can say the difficulties that are induced in this particular gear. Then the dynamic force are developed. So induced. So here we can see the dynamic load, methods to account for the dynamic load. So two different methods are there from which we can calculate the dynamic load. So first one is approximation estimation by velocity factor in the preliminary stages of the gear design. Next one is precise calculation by Buckingham's equation in the final stages of the gear design. Initially, for the sake of simplicity, we can take the velocity factor. After that, we need to calculate with the help of Buckingham equation, so that we will get the actual whatever the dynamic load is there. Next thing is that we'll see in detail how the approximation estimation of dynamic load is calculated. Method is work. So calculation of the exact magnitude of dynamic load in the preliminary stages of the gear design is very difficult. So a velocity factor CV developed by birth is used to calculate dynamic load. So for different three conditions, we are considering the different velocity factor. Now we can see over here case 1, when there is an ordinary situation and commercially cut gears made with form cutters and with velocity less than 10 meter per second. If this particular case is there, in that case we can use this particular velocity factor formula. CV is equal to 3 upon 3 plus V. Case 2, accurately hopped and generated gears with velocity greater than 20 meter per second. We'll use this velocity factor formula. CV is equal to 6 upon 6 plus V. Case 3, precision gears with shaving, grinding and lapping operation and with velocity greater than 20 meter per second. We will use CV is equal to 5.6 upon 5.6 under root V formula. So V is nothing but the pitch line velocity that we can calculate with the help of V is equal to pi d n upon 16 to 10 raised to 3. So now how to calculate the effective load using load factor? So effective load formula is P effective is equal to CS PT upon CV. So the velocity factor is an empirical relation developed by the past experience. So calculating the dynamic load using velocity factor. So these are what the different advantages of calculating the effective load. Ease of calculating the velocity factor and design gears. Velocity factors have the sanctions of the American Gear Manufacturing Association, that is nothing but AGMA, used in past for many years and given satisfactory result. That is why this particular velocity factor is used for calculating dynamic load. Now effective load using velocity factor. What are the disadvantages or limitations? Dynamic load depends upon various factors: mass of the gear, mass connected to the gear shaft, and properties of the gear material like modulus of elasticity. A gear tooth of the material with low modulus of elasticity will deflect more than the gear tooth of the material with higher modulus of elasticity, and other things being equal will absorb energy of impact and reduce the dynamic load. Velocity factor method neglects this factor. It assumes that dynamic load only depends upon the pitch line velocity. So use of velocity factor is restricted to a limited range of pitch line velocities. It is not possible to extrapolate the values. So effective load using dynamic load now. So when the gear dimensions are known, error specified and the quality of the gear determined, the dynamic load is calculated by the equation derived by the early Buckingham. So this is what the Buckingham equation. PD is equal to 21V CEB plus PT, 21V plus under root CEB plus PT. So these are what the different parameter what they are. So deformation factor C depends upon the modulus of elasticity of the material for pinion and the gear and the uniform tooth or pressure angle. So this is what the C is equal to K upon EP 1 upon EP plus 1 upon EG. So here EP and EG are the modulus of elasticity of the pinion and the gear. K is constant, depends upon the form of the tooth. So the values of K are according to the pressure angle. They are given over here that we have to use during the calculation. Values of deformation factor, that is standardized in this particular table. So we can take these recommended values for further calculation of dynamic load. So effective load P effective is equal to CS PT plus PD, with the help of which we can calculate effective load. So error we can calculate with the help of EP. E is equal to EP plus EG, and EP is nothing but error for pinion, EG is nothing but error for gear. So error depends upon these particular factors, and there are 12 types of grades which are shown in the next slide. The expected error of the gear is considered to be equal to tolerance. So this is what the error table, and how to calculate the tolerance value. The formula is given over here, and the grade of the gear depends upon method of manufacture for gears. So this is what the reference is. Thank you.